Hey, how are you doing? Welcome to live stream number 168. I'm a little bit early here. You should have a clock ticking down. If you're watching this recording, this as a recording, I don't blame you if you fast forward about 3 minutes or so. You should be able to use that clock as your guidance. Just want to give people a chance to jump in here, get settled in before we jump into today's live stream. It is Friday, but means we're going to do about CAM, what is absolutely exciting. Looks good. We should be on. Should be decent lighting. Should be decent sound, I hope. Let's see if there's anybody who will join us for this Friday. All right, I can see we got Greg in here. Absolutely appreciate you taking the time as people are coming in. So, yes, this whole thing about starting a couple of minutes early, that is my attempt just to thank you people for taking the time to join these live streams. Nelson is here from Brazil. It's absolutely awesome. But again, if you're watching the recording, just fast forward. That is, I would not blame you for doing that. Eduardo is here. Argentina, absolutely appreciate it. You guys are the best. So today's topic is CAM. So if you're not into CAM, then don't even care about the clock. Go and have a beer or whatever. We're going to cover a couple of different topics today. I think I'm going to hopefully give you some tips and tricks with some machining where it's maybe not all so figured out. What I mean about no fixturing or fancy setups. So I hope that I can share a couple of different tips today. I can see we got Dan in here. Ivan is in here. Orguz, I'm not quite sure how to pronounce your name. I know I'm butchering that. Thank you for watching. I really appreciate you guys taking the time to watch these live streams and the recording. It means the world to me. Absolutely. Do me the favor. If you like the content, thumbs up. If you don't, thumbs down. That is really how I gauge the content. And then, of course, subscribe to the channel. So we got about 40 seconds left here. Let me make sure. Got one question. What is behind my devices? So I'm assuming you have it back on my wall. So over here you got the Haas simulator. What is very close to a Haas CNC control, mostly used for education. You can load CNC programs into it, and you can kind of test them out. You should see right now that it's running some numbers, so that's kind of like running through a CNC program. And then on my other side is my brand new sign that I just got set up. I used Fusion to make that sign, a Stepcraft CNC router, and I'm going to do a video on that. But now time is up on our counter. It's counted down to 0. Again, really appreciate you guys taking the time. Let me just jump in here and get rid of that timer. That will be a good thing here, and then we should be good to go. All right, everybody. Thank you so much for taking the time to join live stream number 168. Today is June 1st, 2018, and it's Friday, what means CAM. We're gonna jump in, and hopefully you do the thumbs up, thumbs down. Hopefully share some useful tips for you when you are inside of CAM. My name is Lars Christensen, and these live stream is just an attempt to add a little bit more value to your Fusion 360 experience. Already got a bunch of people in the chat. Absolutely appreciate you guys taking the time. Also, if you're watching the recording, absolutely appreciate it. Means the world to me. Let's jump into Fusion. So this part here, some of you guys have already been hopefully pretty familiar with it. An airplane wing rib. But I know that some people only join the CAM portion, but it's fine. Don't want to get too far into the design. I just want to give you a quick background because some of you guys have maybe not seen this part, and maybe also wonder why this generative button is up here. So a while back, we designed an airfoil, so like the shape of an airplane wing. And then last week, or the week before, we kind of chopped it into what is called ribs. So this is the sections that is inside of a wing, right? That's kind of like holding the wings together. And I really, when I designed this part, these openings in here that if you're a machinist, I'm thinking, oh yeah, that's tight, not a very tight tolerance. I could machine those. I really just placed those in there from a picture that I saw and my best of my knowledge. Well, what we did in some of the live streams was we went in, because one of the cool things about Fusion is that it has a lot of tools in here. So we went into the simulation workspace and we actually found out if we made this part out of 6061 aluminum, how much pressure could there go on this one before it started to fail and break down. And then after we done that and looking at this, we wonder if there was not a better design. That's where this generative button comes in. Generative design, I'm not going to click on it now, but really it's a brand new tool that will let you use data you already have and come up with a better part. That ended up with this part. So what the generative did was we lowered this aluminum part that was 6 kilos down to about 4 kilos. And what we got out of generative design was this mesh body. And that was kind of like what we used to kind of creating this shape. And you know me, I'm some of you guys know me. I'm not saying you should know me. Some of you guys know me and know how strongly I am within manufacturing. So I made this part here actually manufacturable. And that's what we're going to do today. We're going to machine this part out, or at least some of it. But in that process, I want to share some tips and tricks with you. So I made a new part. I'm calling it Alpha Machining. And a couple of things I want to cover today is setup and machining with stock. I want to show you some tips and tricks. And I normally like to try to set these live streams up, especially for Cam, because there's a lot of different ways you can do things when it comes to machining parts. A lot of different types of machines. You maybe have, big CNC machines, you maybe have small CNC machines, and also one of the biggest things when it comes to making parts is what material, but then also the quantity of your part. And I used to do I started out doing a lot of like tool room kind of machining, and that's what we're going to do today. And then I got into like higher volume where you start thinking a lot about work holding and things like that. I've done some live streams on that. But what I wanted to try to cover today is if you had to machine this part out and you just had to machine one. And this part, by the way, is about, a meter or so long. And if we had to machine this out of aluminum, 6061, and we just had to machine one, how would we kind of approach it? So that's one thing I want to show you. And I also want to show you this little thing. What happens if we apply kind of toe clamps to the part? How do we machine around those? That's a fairly often question I get. So we're going to cover up hopefully some useful things. Again, you let me know. So what I'm going to start out by doing here is let's talk a little bit about side 1 and side 2. So this part is clearly going to have a side 1 and a side 2. Now, a tendency I think we have when we're machining many times is to say, okay, setup number 1, that's where we're going to do most of the work. And then we're just going to flip the part over and then deck off the back, just maybe a face operation or something, and then the part is done. And that works very well for prismatic parts. But with this part here, I actually think that I would go the other way. I would probably, if we just had to make one, flip it over. You can see there's some taper on the outs here. I was going to flip it over, and if this was like out of a big piece of stock, then I would kind of rough out the inside, and then if the top, make sure that the top is flat, of course. Flip it over, and then maybe you could do something where you added some toe clamp, finish the inside of here, the areas we couldn't catch on the first one, and then finish the outside, and then maybe we have to move these toe clamps one time. So we kind of like just go in and blend those areas. So think about this as a part we had to machine just one of. Now I'm going to show you a couple of things here. So we're gonna flip it over on kind of the back, what I would call the back side of this part. And I'm gonna try to do this like right from the start. I did create a sketch on this back side here, and this sketch is a rectangle and a hole. And I can actually go into the sketch. I gave him a name here, so it's a little bit easier to see. That's the one we're looking at. Show dimensions on that sketch there, so we can kind of look at it. So I applied some dimensions on it here. But the idea behind this is that we get a raw piece of a blank of 66-1 aluminum, and I would probably rough out this inside, but this is going to be like a long rectangular part. What happens when I flip it over on the other side? How am I going to pick that part up? So what I would do was I would probably make a witness machining around the outside of the stock. And I either need a sketch to do that or an actually solid. So that's the first reason I created this sketch, right up on this top side here. And then this is actually going to be my pickup hole for the second operation. So when I did this rectangle around here, I mainly created it so I can run a toolpath, because if you didn't know it, you can actually run toolpath right on sketch geometry inside of Fusion. That's actually very handy to know. But since I now had the rectangle done, I actually also extruded this as a stock body. So that's just a build of stock right here that I extruded from that sketch. So when I go in and say, okay, let's open it, go to CAM, and let's create our first setup, you will see that the way I had, this would be what I normally would consider top number one, but now it's actually going to be like the second setup. So the first thing I'm going to do is I'm going to go in here to the orientation, and I'm going to select the Z-axis, and I'm going to select the top here as the right orientation. And I'm just going to select this and select this from the center of the part. So the next thing I'm going to do is I'm going to go into the stock, and inside of the stock, the second tab, I'm going to select from solids. Kind of handy, right? Now you can actually work through the whole tree in here of your model. You don't have to go back and forth and turn it on. We can actually just select it right through here, even that it's not showing. Right inside of the CAM workspace, you can work your way down to the part and select it right there. So now we have selected that stock as kind of like our stock here. So I would definitely do that. So now we have that selected, perfect. Now let's go ahead and start with setup one. Let's throw some toolpath on this one. Now since we're gonna do the inside, I would use adaptive for this. I would probably go here and use the 3D adaptive. I use 3D adaptive more than I use 2D adaptive clearing. The reason for that is 3D adaptive will actually select boundaries of the part, where with the 2D adaptive you have to go in and select edges, and that could be a little bit of a pain in the neck with all these different edges in here. So I'm going to select the adaptive clearing. First thing is always a tool. So let's click on this here, and I'm just going to go down and select the tutorial metric 16 millimeters, because then you all have that. Feeds and speeds should be whatever your tool manufacturer recommend, right? And as I normally do tell you, when we are working with 3D toolpath, just select the tool and hit OK, and take a look at what the software gives you. That is really the best. Really the best process for this. It's not going to take very long, and you're going to start seeing that it's going to start applying toolpath to this part here. Now I notice already that we're machining on the outside of the wing here, or the rib, and I really in this one here only wanted the inside machined. You don't have to wait for the toolpath to finish calculating. You can just right click on it and hit edit. So let me just make sure that that I don't miss anything here. Very important that when I use these 3D toolpath, I just select the tool and hit OK, and look at what I get. I don't go in and change all kinds of things in the settings at first, because that's when you then gotta go back and try to figure out what happened. It gets confusing. So I've already noticed now that I'm machining on the outside. I don't want that. So I'm gonna go into the geometry selection, and you will see that the machining boundary is set to none. So if I go in here, I could actually go in and say selection, and if I select this edge, now it's gonna stay within that. So let's hit OK and just verify that we are on the right path here. So again, the toolpath calculates, and now you will see that it starts within and is going to machine staying within that boundary. So that's kind of tip number one here as we're going through. Now, so like I said, this is kind of the roughing out of the one side of this part, and I'm a little bit concerned when we get to the pickup when we flip it over. So it's a big, you know, it's maybe easier if I do turn on the stock for a second. This is coming out of a big plate. So right now we're machining away the center here, but we gotta continually thinking about that when we machine this side and we flip it over, we better know how to pick it up. So instead of having these toolpaths from the first side going all the way through, I'm gonna make them a little bit shallow. Let's turn the solder off again. Stock off again. I'm gonna make them a little bit shallow, but then I'm gonna have this hole go all the way through the part. So when I flip it over, I can indicate the outside edge straight, and then just pick that hole, and then I know exactly where I am. So let's make sure that this is not machining all the way through. So let's go back into 2D Adaptive. And funny enough, we first selected our tool and hit OK. We noticed that it machined on the outside. Then we went to the next tab, the geometry. We selected that inside edge, and that verified that. Now we want to make sure it's not machining all the way through the part. Well, funny enough, that's the next tab. So these developers, when they came up with this stuff inside of Fusion, they kind of were smart enough. I owe somebody a beer. They were smart enough to think about kind of the order we're working with this. Now, I've done live streams on the height before. The most important thing in the height is start from the bottom and work your way up. The reason for that is whenever you're machining, you're always worrying first about how deep the cutter goes. Now, in this case, it goes to model bottom. I'm going to show you a couple of tips. Right here, looking at the screen, you can actually see how deep this part is, right? It shows you that it's 50 millimeters thick right here. We could actually be pretty fancy. You'll see if I hover over this, my cursor turns into a hand. I could actually just drag this up, and this would actually adjust the depth of the cutter. How fancy is that? I am going to type in 20 though. So now I know I'm machining past that little inside shelf in there, but I'm not going all the way through. So I'm gonna hit OK to that. And now as it's generating, you will know that this toolpath is not going all the way through. Now, of course, one way to check this as it's finishing generating is to, of course, using the simulate workspace, what you definitely should always use. The simulate workspace up here is a little bit like looking into the future of your part, right? So let us just finish here. It's just like 2 seconds. 2 seconds. I have a sip of water here. My office is like 80 degrees. I don't have the air conditioner running because it makes so much noise. All right, there it is. So we could now, with it selected, we can go over here and hit simulate. And we could, of course, turn our stock on. I normally use the wall paint when we're doing the live streams. And now we could hit play, right? And then we could kind of speed through here, take it all the way to the end. Hit the last button down there. And we can kind of see these pockets are not going all the way through. Now we're gonna drill this hole through. I'm not gonna go through all the steps here. First you will normally spot drill and then drill. I'm just gonna cheat and just drill. So I'm gonna hit the drilling operation. First thing is always the tool. And again, I'm gonna use the metric tool here. I'm gonna select the 10 millimeter 180 drill. So maybe it's 120, so it's self-drilling. Hit OK to that. And then you will notice that when you go over to select geometry, there's nothing to select. Because by default, now this is just by default, the drilling operation is looking for faces, and we don't have anything facing here because we use the sketching tool to kind of locate this hole. But if you drop down, you can select points. So now we can actually select this point. That's cool. But again, realize that we haven't selected any type of hole. So we will have to help the tool know the part we're going to machine, or the depth we're going to machine. So we're going to go to height. See, because it's just doing whole bottom. Remember, we're always starting from the top, from the bottom, working our way up. It's looking for whole bottom, but there is no hole. But if I change that to model bottom, now you can see in here that it actually have the hole in there. And we could now also say we want to drill through the bottom, so we get the 118 through. And we can even add a little bit extra, so we make sure we drill all the way through there. Now this brings up a interesting factor because the top height here is set to the whole top. We could actually go in here and say that we want to select, hit selection and select this top face here. And when I do that, here's another little tip. It's actually selecting that plane. Inside of CAM is the same selection tools you have inside of the model environment. If I'm holding down my left mouse button, it would actually give me this little menu where I can actually select through. So I can select that face. That was by holding down my left mouse button. So now we know that the drilling operation is not going to start until it hits this top face and drill all the way through. Okay, so now we drilled through, but I want a good pickup hole. So a drilled hole is not good enough to pick up when we flip it over. So we are actually going to circle mill this one out. Now, if we had a circular hole, a cylinder modeled through and not just a sketch, if we had had a surface hole, I would for sure use the circular mill operation in here. And my reason for that is a very small thing. On the last tab, on the linking tab, you can say lead to center. If you check that, then the cutter will always just start in the center where we just drilled the hole and start out. But because we don't have a cylinder hole, we're going to have to do a little bit of work ourselves, but that's fine. Instead of using the circular hole here, I'm going to use a standard contour operation. I am going to select the tool. I am going to select the metric 10 millimeter flat end mill, because that's a good sizing end mill. I am going to select as geometry that hole. Again, remember, we can drive sketches with toolpath. We don't have to always have a 3D model to drive in here. That's pretty cool. Now again, when we go to the next tab, the heights tab, this tool is not going to know how deep it's supposed to machine because it's looking at the selected contour. But if we select model bottom, it will. And we could again do what I did before. The top height is by default the stock height. But since we machined all that stuff inside of here, we can go in and say selection. But because the plane is our way, I'm going to hold down my left mouse button. And this little menu is going to appear. And then I can select it. So that's where our operation is going to start from. Now this is just a contour toolpath, so I manually would have to select multiple depth on. So I'm going to do that by 2, and then I'm going to wait with the center, starting from the center, just to show you what we got so far. So now you can kind of see we got that operation starting from there. It's going to do 2 millimeter step down to kind of clean out that hole. It's a little bit hard to visualize right now, but just in 2 seconds. Now I want to come back to if I go to the top view here, we look from the center. So one of the great things, as I said, with the circular operation is that it will start from the center where we drilled that hole, and then the lead in, lead out would go back to center. We don't have that in this 2D contour, but be aware of that, again, I owe the developers beer and steak, that in the linking operation in here, you do have full control over the lead in and lead out. So I can actually go in here, and if I change this to 5, hit OK, you will see that now my lead in got pulled closer towards that center point. And if I then go back in and I do something like maybe 100 degrees in the sweep angle, now we're very close to that same kind of movement where it's going to come down, plunge down to the center of the hole, our drilled hole, and then start machining that out. So let's verify this just so we can get this this set. So I'm going to select this top setup, hit the simulate. Now I'm going to fast forward through the first operation by clicking here, because we're kind of like already seeing those pocket tool path happens. So with that done, we can now just turn it down. We're going to let go, and it's going to drill. So it's going to start drilling all the way down. That should go all the way through the bottom. And then our circle mill start here, and you will see that it's going to go right into the center, right? So we'll also do something with the recheck height. It's going to do a couple of these. I could have actually gone, I should have gone down to the near the top of the bottom here. I just did the top of this surface, so we're going to have some couple of wasted movements there. But it's going to machine that out there and interpolate that hole, so that hole is a good pickup hole. Now I still want to clean out, last thing I want to do on this side is I still want to clean out the outside of this one. So to do that, I am going to do another 2D contour. And remember, this one I'm going to go back to our 16mm flat end mill. And again, I can drive, my whole reason for making the outside rectangle is I can drive that rectangle. Just remember, then this red arrows will let you control what side the cutter should be on. Because we're driving a sketch geometry, right now it's not looking at the solid. It's just driving a sketch. So what I'm trying to say with this is you can actually just draw sketches and you can completely cam it inside of Fusion. It's pretty cool. All right, I gotta talk a little faster here, so we're running out of time. So now I've driven that sketch. Again, we gotta do the depth. Now, this one here, I'm kind of assuming that we are holding this in a vise. So I'm just gonna go minus 25. That should take us about down to the middle of the part here, right? So now what we have is we've roughed out the inside. We drilled a hole through, we interpolated that hole, so it's a good pickup hole, and then we machined the outside around here just to clean up the stock. So when we flip it over, you can indicate that edge in, and you can pick up that hole. Now, I wanted to show you a little tip that you can actually bring this stock with you. And I'm gonna run over a half an hour today, so sorry if you only had a half an hour. But this is going to be good. So I'm going to actually select the whole setup again. I actually don't have to hit the play simulate button. I can just fast forward to the end here. Take a second. You see the red bar running down the bottom. There we go. So now we have done all our 4 operations here. You can actually now, if you are inside the simulation workspace, right click and go to stock and say save stock. Now this is going to save an STL file. I'm going to throw it right on my desktop as a stock. So now we have an STL file of the stock here. Now I'm going to answer a couple of questions that I've gotten from people. First of all, I actually don't need to bring this stock back in to Fusion to use it for our second setup. But people are asking, when they're bringing in STL files into Fusion, why do they come in too big. And the reason is that they're using the data panel here to upload it. What you need to do if you got to bring in a stock is to go to Insert, or it's an STL file, go to Insert, Insert Mesh, and then bring it in. Now you will actually see that I just brought that mesh body free in there, and that is now our stock. And now it's same size as our part. So there's the STL file, and there is our part. So now you can kind of see that they are together. But I actually don't need to bring it in into CAM if I want to use it for second setup. Only if I had to use it for like a tombstone or a different fixture location or something. I'm actually just going to delete it again. I'm going to show you in a second how I'm going to use that STL file that I saved. So with this here, let's say that the part is, and I know there's a couple of things with this part that doesn't make it machinable or question about it. We probably would have a radius down here in the bottom, and also this end here would probably be redesigned so it was not that tight and sharp. But bear with me. I only have so many hours to prepare for live streams. So now we're gonna flip it over to kind of like the finish side, right? And what means that we machined that bottom, and now we are ready to pick up this part. Now, before I get to the whole thing about having clamps on here and move them and stuff, let's just talk about the setup first without that. So let's just talk about machining the inside on the second side here. So I'm going to jump back into CAM. And by the way, if you wonder why these are now red, was because I brought that STL file in and CAM noticed that there was something new in there. All you have to do is regenerate it, generate the toolpath. Nothing's going to change because we didn't change anything on this specific model, but it just flags you. Actually, here's a little tip that you hopefully find helpful. What I used to do with CAM was that when I had verified the first setup that all these settings were the right ones, and I was kind of ready to post code, I would actually select all of the ones and I would right click and I would hit protect. You will see that that creates a lock on them. That means that they will not be regenerated again. So I would normally, whenever I had kind of like verified, simulate my toolpath, feeds and speeds are right, step over is right, and I was ready to now move on to second operation, I would lock them. So select them all, right click and protect them. So that way I kind of, not only do I make sure that if something was changed in the model, it didn't just update without me knowing about it, but also it was kind of like just a reminder to me that, yep, I had verified those and those were good to go. All right, let's insert another setup for this part here. And we could actually just go in and select that stock again. Go to relative size box in the stock setup. Select the stock over here so we get the same stock. Now, when it comes to this pickup point, we actually want not only to make sure we have the right orientation, but it's fine here, but we also want to make sure that we can actually select this point as our stock point. Be aware of that that's where we can go here in the origin and we can pick a selected point. And now you can actually select this point as your origin, and that's where now your G54 would kind of come from. So just be aware of that you can select that there. Okay, I want to show you another neat tip here that you hopefully you knew, but if you don't, you need to know about it. So this first adaptive that cleaned off the backside here, I actually want kind of like the same adaptive for this operation over here, right? Did you know that if I just do, if I do a Control C, Control V on this operation, I can copy paste that adaptive down to that adaptive, and because all we're doing is flipping the direction, and we're using the adaptive free axis that analyzes the model anyways, I can literally just regenerate this, and this toolpath will now completely fit inside of here. If we had done, because this pocket is actually a little bit tighter, a little bit smaller than this other pocket, because there's a tape on this wall. If we had used a 2D adaptive, we could not have done this. But because we're using that 3D adaptive that analyzes the model, all we have to do is going in here, edit the toolpath, and the chain is going to be this chain instead. And then that is actually completely on there. So a little neat trick to quickly get that second operation in there. And that brings me up to show you using that stock that I saved out as an STL before, but I deleted it from inside the file. It's not inside the file. If I now, it's gonna finish generating here. 2 seconds. 3, 2, 1. 3, 2, 1. 1, 2, 3. It's right around the corner. It knows it's Friday. It's slowing down. There we go. If I go and hit simulate, you will see that it's using the stock that we specified in the setup. And you're like, yeah, that's what it normally does. But now we can actually right click here and go back into stock and say load stock. And we can select that STL file. And as soon as I do that, you will see we get the hole there, and we get that operation in there. So that's one way you can use that. That went too fast, just rewatch the video. Now I will show you another little tip. So when I click the play button, you will see that the lead in here, it rams in where the stock is. Well, I'm like one of these guys. I'm like, no, I want it to be in that hole. That's actually also fairly easy. Just go back into the adaptive, edit, go back to the linking, and right here you can select entry precision on the last tab on the LinkedIn tab. Select that point, hit OK, and now you will actually see that it's going to start in that location right here. It's just generating that here. So now it's going to ramp, and now we could change that to a plunge, at least for this one here. Of course, it's going to have to re-ramp over on these sections over here. Just wanted to kind of show you that there is a lot of different control inside of here, and I don't think that this is always the easiest to find. So let me just simulate this, and then I'm going to show you the last thing with the clamps here. So hopefully this is good stuff for Friday. It's almost done. There we go. So now I just want to show you again, when you go to simulate, you will not see the stock. But if I right click and load the stock, that's the one way that you can kind of bring it back in here. And turn the sketches off for a second. And now if we go in here with simulate, now you can see that the stock's in that hole there. And now we will see that we will get the right pockets. And this is one of the reasons that I like to use load stock, is because I kind of want to see when we get to this point here where we are breaking through into the different pockets. So here you can see how we're getting those pockets up, and we kind of get a good visual of what we have on this side versus of what we have on this side here. So I hope that this was some good tips. Last thing I want to show you, then I'm going to shut up. Last thing I want to show you is if you apply clamps. And you could just sketch these up, but I actually like to just bring in the toe clamps. I normally make a 2D drawing, so when you set it up at the machine, you know exactly where to place them. But the trick is that if we got to machine the outside of this plate here, remember that we have this whole plate here. If we got to machine the outside area, how do we make sure we don't hit these clamps? Well, the trick is to make sure you have them in here, and then when you do your setup, I'm going to create a new setup. Create your setup. Make sure that those are included in your model environment. So what do I want to include in here? I want to make sure I include the part I'm going to machine, but also that I have each of these clamps included. Then it would actually take that into account. Now I can still select my stock from a solid body, that's fine. That the stock is from that billet. But you want to make sure that this is selected here. And then I'm going to show you one more tip that is important, because you will see that now when I go and hit a adaptive clearing, I'm going to use that same end mill, and I'm going to hit OK. And it starts calculating. You will actually see that it calculated extremely fast, and that's normally not a good sign with adaptive. And if we go and we expand it, you will see that it says none, meaning there's no toolpath in here. Now, I just did a live stream on how to troubleshoot this kind of stuff, and it can be a little hard, but the tip here is to right click, go in and say show log, and it show you that it's a Z clearance issue. And the Z clearance issue should give you an indication that this is because of the heights tab. So I'm going to edit the 2D adaptive. I'm going to go into the heights tab. And the issue is that it's looking at the stock top to be the top height. But remember, we now have these clamps that are sitting above it. So what I'm going to do instead is I'm going to select those as my top height. I'm going to select my retract also as that selection. And now when I hit OK, you will see that now it actually starts generating toolpath. And this is, this is something that could definitely throw you for a loop. Now it's going to start applying the toolpath here. We're going to start seeing them just in a second. You will see it starts machining on the outside. You will see that it avoids the clamps. Now you might want to model these clamps a little bit bigger than the ones you have on your shop floor, just so you have a little bit of clearance. But this is a way to get around the issue where you want to have these clamps. So by having them in the setup, selected in the setup, Fusion is actually smart enough to avoid those. Now, as this is calculating, I'm noticing this one is re-machining the inside. And you're like, dang it, that was what we did on setup number 2. I'm going to leave you with this last tip. Yes, that is true. So in setup number 2, if we go in and edit that one, we selected that inside boundary edge, right? That's what we've been doing all the time. Well, did you know that if I turn the stock back on, that if we go back to this new setup number 3 and edit that if we select an inside boundary and an outside boundary, so this is why I just turned my stock on, so 2 selections, then Fusion will actually calculate between the 2 boundaries. So this is the way to make sure that this second adaptive will machine on the outside of the clamps, not hitting the clamps, and make sure that it stays away from the inside palette there that we had just selected. Now, I'm not going to do that in this live stream because we're already about 10 minutes over what I normally like to show. But what would I now do when it comes to, why is it still machining the inside? Wait a minute. Oh, it's machining on the top up here because I set the top height to up there. So that would actually mean that we don't really want to set the top. If we set the selecting height to the selection top reference, if we just leaving this at selection and we do this at the stock top, that should be better. So what I did before was I selected the stock top as the top of here, and then the retract height to be, but it's actually just the retract height. I think that has to be up here where the clamps are. We can still machine from the top of the part. Let's just make sure that I'm not, well, then I have to come back and look deeper into this. I was ready for celebrating a early Friday here. This is always good about live streams. Let's see what we get. It's like It's like Christmas. There we go. Now it should only do the outside, but still avoiding these clamps. That's really what we want here. We didn't want it to have all that machining empty air as it would have done. It would have machined from the top of those clamps. Oh no, it's still doing something. You still want to touch that boundary right on the surface there. All right, I'm gonna have to look into that. Now, last thing I want to say is, so the way I place these clamps was I literally just used the move tool that I talked about yesterday in the live stream. So if I, for example, right click and say move, I can select one of these components, and I would literally just, well, now they all are moving because they all are copies of one another. Of course, I would have done that a little bit differently, but I have live streams on that. So I would select these, or you could make another file. There'll be another way to do this. Have a file for the second operation. That might actually be what I would do, have a second file. But now I could move these clamps. I just moved them visually like this. And then the section where I now need to machine, I would actually just probably again use an etch or use a sketch as kind of like the confinement area. And blending that in there. All right, I went way over today on a Friday, but I hope that this was not creating more questions than answers. I hope that this kind of like gave you a good idea about how to attack something like this. A little bit like, I would say, what I would call past phase. You're standing at the shop and they come in, they're like, we only need one of these, go. Where you don't have all the different fixtures and everything to kind of like design. That's really what I had planned on showing this Friday. I hope that you enjoyed it. A little bit of cam stock setup and some reusing stock for second setup, and then of course some of the machining boundary things in there. Hope this was useful. If you're watching recording, thank you so much. If you are in the live stream, I really appreciate you taking the time. And I'm going to do in the live stream. Really appreciate you taking the time. And until Monday, have an awesome weekend, folks. Take care.